Welcome to today's lessons on Newton's first law of motion, also known as the law of inertia. Let's join Professor Newton and his student, William, as they explore this fascinating concept.
Good morning, students. Today we're going to learn about my first law of motion. Will you be willing to help me with a little experiment?
Sure, Professor Newton.
Great. William, can you give this ball a little push?
BBL Drizzy. BBL Drizzy. Woo! BBL Drizzy.
Did you see that? When you pushed it, the ball started moving, but then it stopped. Why do you think that happened?
Maybe because of friction?
Exactly. Friction is the force that opposes motion. The friction between the ball and the table is what led the ball to stop. Without friction, the ball would go on indefinitely. Now, let's imagine there was no friction at all. What do you think will happen?
Would the ball keep rolling forever?
That's right, William. This is the essence of my first law. An object in motion stays in motion, and an object at rest stays at rest, unless with the same speed and in the same direction, unless acted upon by an unbalanced force. Let's try another experiment. William, can you roll the ball up this ramp? Notice how the ball went up, slowed down, stopped, and then rolled back down. This is due to gravity. Gravity is the unbalanced force that's acting on the ball. It pulls the ball back down after it loses all of its kinetic energy. Now for a bit of magic. What if I removed all forces acting on this ball, like friction and gravity? What do you think will happen?
It would keep rolling forever, right?
Exactly. This is my first law in action. For example, in space where there's no friction, objects can move in a straight line and at a constant speed until it's acted upon by another object. This is why space debris and satellites are able to orbit around Earth and other planets for years without stopping.
They not like us, they not like us, they not like us. They not like us, they not like us, they not like us. You think all they're gonna disrespect Kirby Beta? I think Jerbo got a 3 conceits of Beta. But that kinda broke my physics project. I don't know why he still pretended. Kinda cut my grade, but he gonna get stitches. So objects don't just start or stop moving on their own? There has to be a force involved?
That's right, William. Inertia is the property that resists the change to the state of motion. The more mass an object has, the more it will resist any change to the state of motion. That's why it's more hard to push a car than it is to push a bicycle.
That makes sense. So when we're driving a car and it suddenly stops, we feel like we've been thrown forward because our bodies want to keep moving, right?
Exactly, William. That's our body's inertia. That's why the seatbelts we wear counteract the inertia. They also are the unbalanced force that prevent our motion in a sudden stop.
And in sports like soccer, when you kick the ball, you're applying a force that changes its state from rest to motion. And if there's no force to stop it, like another player or a goalpost, it would keep moving until gravity and friction slow it down to eventually stop it.
Yes, William, that's a great example. When we make the kick on the ball, it overcomes the ball's inertia to set it into motion. And if there was no unbalanced force like another player or the goalpost, it would keep moving until gravity or air resistance would bring it down. And that's Newton's first law of motion. Remember, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. Stay tuned for our next episode where we'll explore Newton's second law of motion. Until then, keep exploring the wonders of physics.